Well, if you're watching this video, it's because you want to do something about solving formulas. This is Unit 2, Section 6. And the thing is about formulas is that, and I like working with formulas because, well, they're always the same. They never change. For example, if we're talking about the perimeter of a rectangle, the formula that we're going to be using, and we're going to be using this quite a bit in this and subsequent chapters. The thing is that about a rectangle, if I were to take 2 times the width plus 2 times the length, I'm going to get the perimeter. Or if I'm looking at the area, I know that if I take the length times the width, I'm going to get the area of that rectangle. And the area of a circle, you know what the area of a circle is, right? Area is equal to what? Right, pi r squared. How about the circumference of a circle? See, the circumference is equal to, do you remember what it is? How about pi times the diameter? Or you could be using C, the circumference is equal to, and it's since the diameter is actually 2 radii, we say 2 pi r. And one we're going to be studying quite a bit in later chapters is the slope-intercept form of a line. That's y equals mx plus b. And the thing is about these formulas, we have to realize that all of these variables are actually numbers. Because if I knew what the width was of a particular rectangle and the length, I could find the perimeter for, or if I knew the length and width, I could find the area. And these are actually numbers that we could plug into these formulas. Well, the reason why we want to know that is because if I were to take this formula, P is equal to 2L plus 2W, right now we have the P by itself, right? We know what P is. We can find P by taking twice the length plus twice the width. Well, let's say I wanted to get the L by itself. And that's what we're going to be doing here. We're going to be solving these following formulas for the variables indicated. In other words, whatever the variable that's being indicated, get that variable by itself. And what we're going to do is we're going to manipulate this formula so that the L is by itself on one side. So the first thing I want you to do is actually put a circle around the L. Now, I didn't say the 2L. I just want a circle only around the L. And the reason why I want you to do that is because you leave that alone. Leave it alone. Don't do anything with the L. And what we're doing is, inspecting this problem, if we got rid of the 2 and got rid of the 2W, if we took those and wiped them off that side of the equation, wouldn't we have the L by itself? Well, that's what we're going to do. We're going to get rid of these other terms, this 2W here and this 2. We're going to get rid of those. We're going to put them onto the other side of the equation, and when we do that, we'll have the L by itself. Now remember, these are just numbers. They're terms. And just like solving any equation, if we need to get rid of the 2 and the 2L, which one are we going to get rid of first? Which one do we need to cancel out from the right side of the equation? And if you remember from last chapter, what we were talking about, or previous sections, what we were talking about doing was starting with the number that's what? Farthest away from the variable. So looking at the 2 and the 2W, which one is physically farther away from the variable L? Well, the 2W is. Well, it's being added, so what are we going to do to cancel that out? How do we cancel plus 2W? Now, always keep track of that equal sign and where it is in the problem. Let's redo that. Let's do minus 2W here. All right, now, always keep track of that equal sign, bringing it straight down, Now, look what happens on the right side of the equal sign here. The 2w and the minus 2w, they cancel each other out, and that's what we're looking for. We're looking to cancel that 2w from that side of the equation. And notice that I have 2l on the right side of the equation now. Now, I don't care what's on this side of the equation. It doesn't matter what's over there. We're going to simplify it as much as we can. Now, and read this to yourself. What does that actually say there? Well, doesn't it say P minus 2W? So that's what we're going to write. We're going to write P minus 2W. All right, now, again, I don't care what's on the left side of the equation. My whole objective here is to get that L by itself, and I need to cancel out that 2. So think about it. If you had 14 is equal to 2L, well, what would you do to both sides? Well, you divide by 2, right? Just because you don't realize, you don't understand, or it doesn't make sense what's on the left side, it doesn't make any difference here. The rule doesn't change. I still need to cancel out the 2. So what I'm going to do is I'm going to cancel out the 2 that's with the L there. So I'm going to cancel that out by dividing both sides by 2. And when I say both sides, I mean literally you take the entire side and divide it by 2. Now, what we've done here is we've isolated the L. The L is by itself. So L is equal to, and what do we have here? It's just P minus 2W over 2. And you've solved your first formula. This second one's a little bit easier, right? I need to isolate the W. Circle that, because we don't do anything with the W. What we need to do is cancel out the L. It's L times W. How do we cancel the times? By dividing. So I'm going to divide both sides by L. W is equal to A over L. Number 3. Now I want to get the R by itself. So here's the R. Circle it. We need to cancel out the 2 and the pi. They're both being multiplied times the R, so we can divide both of them by 2 pi. Whatever you do to one side of the equation, you do to the other side of the equation. I always notice that I always bring my variable over to the left side, and I get R equals, and then this is just C over 2 pi. Now, number 4. Go ahead and pause the video and see if you can do number 4 on your own. And when you come back, when we come back, we'll play I'll show you exactly how to do that. So go ahead and pause the video, solve for x. So hopefully what you did was you started by circling the x. I want it by itself. Don't do anything with the x. We need to get rid of the m, and we need to get rid of the b. Well, which one is physically farther away from the x? Well, the b is. So in order to cancel out plus b, we do minus b. Do the same thing to the other side of the equation. On the right side, I have mx. Read to me and read to yourself what you have on the left side. Doesn't it say y minus b? So that's what you write. You write y minus b. Now, in order to get rid of the m, we need to divide that by m so that they'll cancel out. Look what I have by itself. After the m's cancel, I'm going to have the x by itself, so I'm going to divide both sides by m, and I get x is equal to y minus b all over m. In number 5, very similar. We're going to cancel everything out except for the y. We need to start with the thing that's farthest away. Now, see this minus sign here? Does that mean I add 3x to both sides? Or because the 3x is positive, do you subtract 3x from both sides? Well, because it's positive, we're going to go minus 3x. So the 3x minus 3x cancels out. You're left with what? Right, negative 4y is equal to, and since we cannot combine these terms, do not say that 7 minus 3x is equal to 4x. These are not like terms. They can't be combined, so I'm just going to write it 7 minus 3x. Now, not paying attention to what you have on the right side. It doesn't matter what's over there. What matters is getting the y by itself. And what do we need to do to get the y by itself? Do we need to add 4 to both sides? It is a negative 4, right? But it's negative 4 times y. So to undo, to cancel the times, we divide both sides by negative 4. So the negative 4's cancel, and I have my y by itself. That's what I'm looking for. So what do I have on the right side? 7 minus 3x all over negative 4. Now, one thing, and anyone who's a purist who's watching this video will know that we're not supposed to have a negative in the denominator. The way this is written, I'll accept this for my Algebra 1 class for right now. A little bit later on, we're going to discover how 7 minus 3x over negative 4 is the same thing as 3x minus 7 over positive 4. I'll accept this, but for those who are watching this and know that we cannot have negatives in the denominator, it'll be 3x minus 7 over 4. But that's for another day. All right. Number 6, take pi, circle it. We have it times r squared. So how do you undo the times? You divide both sides by r squared. And I get pi is equal to a over r squared. Good luck on your assignment. I will see you in class next time.